My name's Carol Turley and I'm from Plymouth Marine Laboratory.
And as credited in the movie, if a little credit shows up underneath your name, what would you like that to be?
Dr. Carol Turley, Plymouth Marine Laboratory.
Okay. And you know about what's happening with the oceans and carbon. Can you give us a little, 30-second brief on what's happening with ocean acidification?
Okay, we're emitting CO2 into the atmosphere. Since the Industrial Revolution, we all know that CO2 in the atmosphere is increasing, and we know about global climate change. But there's another issue, and that is when the CO2, the carbon dioxide, that's in the atmosphere enters the ocean, it reacts with seawater and forms carbonic acid. And this makes the oceans more acidic. So the pH, which is the measure of acidity of the oceans, is decreasing with time. It'll never be acidic, but it has a ramification to the rest of the chemistry in the oceans and could affect in the future marine organisms that produce shells and skeletons out of calcium carbonate, like coral reefs and some of the things we eat, like seafood, shellfish, lobsters, crabs, and that sort of thing.
And saying that it could affect these guys, what kind of effects would it have on animals that produce carbon?
Well, in experiments that scientists are carrying out by putting them in CO2 concentrations that we may get by mid-century and at the end of the century, we're seeing a reduction in shell size and shell strength of different shelled organisms.
And what, in terms of business as usual, what would that mean for the future for the oceans and coral reefs?
It makes scientists very concerned about the survival of many of shellfish and corals. Some scientists predict that by mid-century, the rate of coral reef growth will be less than the natural erosion that corals undergo. So corals may well start declining around mid-century.
And if there was one thing about acidification that you wanted the entire world to know, what would it be?
If you consider 1 billion people on the planet depend nearly totally on marine food protein, that is fish and shellfish, and if we're seeing a loss of both and a decreasing health and ability to survive of many of the actual organisms that we eat, and also key links in the food chains that support fish and things like that are also sensitive to acidification. Plus, some of the ecosystems that support diverse fisheries, such as the coral reefs, both the tropical coral reefs and the cold water corals, which can be as important as the tropical coral reef cousins. So it's the decline of ecosystems, the potential loss of some links in the food chain, as well as some impacts on food providing organisms. And if you think by 2040 we're going to have a population that has risen from around 6 to 9 billion, and they're looking for marine food supplies to help feed those. So it's a real concern. We are worried about the risk to food security.
Okay.
And you should really ask, how can we stop ocean acidification?
How can we stop ocean acidification?
The only real way to stop ocean acidification, because it's a global issue, it's a direct causal relationship with the CO2 we put in the atmosphere, is to reduce our CO2 emissions. It's as simple as that. The solutions may be difficult, but that's how to remedy the situation. And if we don't, then the oceans will become more and more acidic, and that will last for tens of thousands of years before the oceans eventually buffer it all out. So it is persistent.
Now, the oceans have been more acidic than they are now in the past, though, right?
not for around 65 billion years. So over the last 20 million years or so, the ocean pH, the ocean acidity has on an average has remained quite constant. And the change that we're going through now, and if we keep emitting CO2, it will be the greatest change that we've seen for around 65 million years ago, which is when the dinosaurs died out. So that what we're doing now is a rare event in the history of the planet, and it's man-made.
Now, why is it important for you to come to COP16?
They're negotiating about emissions of CO2. We need to make sure that the issue of ocean acidification is raised here. It's a climate change conference. Ocean acidification is the twin sister to climate change, but is getting little attention in the negotiations because the issue's only recently emerged. We're trying to bring that to the policymakers so that they can incorporate that in the whole climate mitigation negotiations.
Now, do you think oceans and acidification are properly represented here at COP16?
No, unfortunately not. Being organisms that live on the land, humans tend to focus on the land, and the oceans, which are our life support system, they produce every second breath of oxygen that we breathe, and they fix half of the productivity, half of the carbon, the productivity, through the marine plants. So there are equivalent to tropical rainforests in the oceans that aren't really getting attention.
And how can we draw more attention to the oceans here?
Keep talking about it. Produce films. You know, get the children, everyone to talk about the oceans. They are our life support system, and they are really, really important in uptake of carbon and as a food resource, and biodiversity. It's hugely important.
Why is biodiversity important?
Well, the biodiversity in the oceans is just absolutely huge and diverse, from the deep, deep oceans to the shallow coastal systems like coral reefs.
Why?
Why do they harbour such great biodiversity?
Why is it important, biodiversity?
Why is biodiversity important? It's important because all those genes there are locked up within those organisms, and so as things change, then that diversity could evolve in time. And also, I think human beings value the wealth of biodiversity that you'll get in a coral reef, for example. You know, it's important economically to many countries. There are coral reefs, healthy coral reefs that enable us to not only eat interesting and diverse organisms, but actually go and view them. And we all love the Nemos of the world.
So it's an important issue for sort of our selfish interests of having these things around it, or more so important because it's necessary for the ecosystem?
It's also necessary for the ecosystem. The complexity of the marine ecosystem is massive, and every little organism has a role to play in that.
Okay, in terms of the oceans being represented here at the climate conference, what's your impression on their relevance and how this climate conference considers
the oceans don't seem to be well represented at the COP16. The small island nations are actually speaking up for them. I don't really know why that is, but we are land-based organisms, and we often forget that the largest part of the planet are the oceans, and they make up about 98% of the living biosphere. So they are hugely important, and yet seem to be getting little recognition here. We come to things like COP16 and speak up for the oceans, and of course part of communication is listening. And we will hope that at this negotiation process that we'll actually manage to get oceans considered in the future?
Now, I've heard some.
Sorry, the noise. Yeah.
I've heard some stats, or not stats, but research on acidification affecting, clownfish, affecting making fish swim towards predators, these kinds of things. Did you have any information on how ocean acidification has been seen to affect specific species?
There are a couple of papers that show that some of the reef dwelling fish, like the clownfish, their olfactory, their sense of smell is affected, so that they don't swim away from predators, so they stay around predators more. And the scientists involved have done some calculations, and their mortality rate may increase by five times because they're not predator aware. And the other lovely bit of work that's been done is that the baby clownfish disperse off the reefs, and they have to have a good sense of hearing and smell to find the reefs when they get older and get back. And it certainly seems that from these results that they have problems relocating home. So Nemo may not be able to find its way home, I guess is the message from that.
In terms of the most recent research on acidification, what are some of the stats or some of the numbers that the layperson will understand to show how significant an issue this is?
I couldn't hear you. I'm really sorry from the noise.
In terms of recent stats and findings on ocean acidification, what are some of the numbers that would make this issue make sense to the layperson?
Already the oceans have taken up around 25% of the atmospheric CO2 that we've emitted in the last 200 years since the Industrial Revolution. That has already turned the oceans 30% more acidic, and by the end of this century, or even mid-century, that could be 150% more acidic. In terms of impacts on organisms, there have been about 140 studies on impacts on specific species, specific organisms, and the great majority show negative impacts, although sometimes there are positive impacts as well. There are winners and there are losers. Some of the winners may not always be, what we call good species. They may be ferocious predators, like a massive sea urchin that may then eat that ecosystem out. So it all depends on how the ecosystem balances itself in the future. One of the big problems we have is upscaling these experiments to predicting what might happen, how an ocean ecosystem might look like in the future, and what it may be able to provide mankind, and that is really hard to predict. That's crystal ball watching. But I can tell you that scientists all around the world are really concerned. And one of the windows into a future high CO2 world are vents, CO2 vents, carbon dioxide vents in the Mediterranean. And these have been there for a long period of time. So the scientists are able to do a transect into the vents so that they've got a gradient of acidity as they move towards the vents. And close to the vents, there are no calcifying shell-producing marine organisms. The further away you get, the greater they build up. They become what is normal again. And things like seagrasses actually do well close to the vents, but the whole biodiversity decreases, and some alien species actually that don't mind ocean acidification move into the niches that have been vacated by the loss of the calcifiers there. So again, that's another indicator that a future ocean may be less diverse and may provide less food-providing organisms.
Now, through things like phytoplankton that help provide the oxygen in the air that we breathe, does ocean acidification affect those?
Some of them, but not all of them.
Is there any studies to show what or how or?
Sorry? attacked.
Not getting attacked.
Yeah.
Are there any studies on acidification's effect on phytoplankton?
There are, and there are some calcifying phytoplankton called coccolithophores, and they produce little, what they call liths, little plates of calcium carbonate around them. And there have been about 15 or 16 studies on this, and 15 of them show that the liths, these plates, these calcium carbonate plates, have holes and are misshapen as the CO2 is increased.
So, from the scientific community, is there any concern that acidification might affect, the air that we breathe?
I think you need to come back in about 5 years before we can answer that question. Yeah.
Is there any particular outcome from a policy perspective, or anything that you'd like to see come out of COP16?
I would love to see the oceans being taken into account, and I would love to see strong and urgent mitigation of CO2. And I would like to see the island and coastal communities being taken into account in any adaptation or legal process.
Can you tell me a little bit about the trickle-down effect?
Well, one of the difficulties in examining ocean acidification impacts on marine organisms is that there are many different life stages. So you've got adults and you've got larval stages that get dispersed in the seawater, and others may then they have to come back and settle on perhaps hard sediments. So there's a whole range of different parts of the life cycle, and when in order to study the true impacts, it means you have to look through the whole life cycle of the organism to look for, in a sense, the most vulnerable parts of the life cycle. In addition, you've got all sorts of processes going inside that organism. It has to calcify shells, it's got to maintain its body and its metabolism, it has to put effort into reproduction and dispersal of its stages and maintaining musculature and so on. And of course any aspect of that could be impacted by ocean acidification. So it's not just calcification and shell production. There's a really good example of this, and one study carried out on the brittle starfish, that when it was put in a high CO2 environment, it started to calcify, so it produced more and more shell. And it's like it was a response saying, oh my God, I need to do something about this. And so it's produced more and more shell. But when we looked inside its arms, it had done it at the expense of its muscles. So this would not be able to continue for long. So it's like an adaptation to a short-term acidification, but of course it wouldn't be able to do that for long periods of time. So that's why you mustn't just study calcification, you must study other processes as well, including embryo development, larval development, and so on. So to get a full picture of that.
The last time the oceans went in this direction, you said it was about 65 million years ago. Do we have any idea what the oceans looked like then? Were they teeming with life as they are now? Was life different or just differently adapted to the conditions?
It's quite difficult to study organisms back then. A good example is around 55 million years ago, where they think there was a strong acidification event. And the event was over several thousand years, whereas what we're doing today is over several hundred years to decades. So the timescale is totally different. We're doing it faster now. And back then we can only judge of what the impact was through looking at the calcifying organisms, because those shells are preserved. And around 50% of the seabed dwelling calcifiers became extinct. And it took tens of thousands of years for organisms to recover from that. So what we're doing today is really a rare event in Earth's history.